Okay, this is the free response number 1 from 2016. So it's saying that water is going into a tank, so going in is W of T. And it's only talking about from 0 to 8. And then water is coming out, so going out is R of T. Okay, and when T equals 0, there are 50,000 liters of water in the tank. Okay, so for part A, it's asking you to estimate R prime of 2, which means you want the slope at 2. So you're going to use the points on either side of 2, which would be 1 and 3. And then you're just going to do y2 minus y1 over x2 minus x1, and you should get negative 120 liters per hour. And because it's the derivative, it should be squared, but I don't think you'll lose any points if you get the squared. Okay, so that's part A. Okay. Part B is saying to use a left Riemann sum with 4 subintervals. So we're going to use the intervals from 0 to 1, 1 to 3, 3 to 6, and 6 to 8. So we're going to use 4 of them. So I'll get the length for each one. So from 0 to 1 it's 1, from 1 to 3 it's 2, from 3 to 6 it's 3, from 6 to 8 it's 2. So now I just need the height of each. So if we're using the left, we're going to use these values, the one on the left. So at 0, we're getting 1340. At 1, we're getting 1190. At 3, we're getting 950. And at 6, we're getting 740. So when you calculate this, you should be getting these values. Okay, when you add all this up, you get 8,050 liters. So the question is this an overestimate or an underestimate of the total amount of water that's removed? So going back, the water that is removed, that's going out, that's this one, R of T, and R of T is the chart, so that's what they're talking about. So if you look at the chart, you can see that all the numbers are going down, they're decreasing. So if you have a function that's decreasing, and you use a left Riemann sum, you can see that that's going to be an overestimate. So you're going to write, because it's a left Riemann sum, the amount being removed is an underestimate. Okay, and that was part B. Okay, for part C, use your answer from part B. So from part B, our answer was 8,050. So you're going to have to use that answer to find an estimate of the total amount of water in the tank. Okay, so the water in the tank is going to be the 50,000 we started with, plus the integral from 0 to 8 of the water going in minus the water going out. Okay, so 50,000. And then we could break this up into 2 integrals, because we already know what one of them is. Okay, what we just found was R of t. Right, that was the water going out. So that one is the 8,050. So all we need to do is to find that piece. Okay, and this is a calculator question. Okay, so I'm going to run out of room here. Maybe I could do it up here, do it in a different color. Okay, so we're looking from 0 to 8 of W of t, and they gave us W of t. So you're going to just do that on your calculator with the Math 9 function, and when you do, you're going to get this. That's an 8. Okay, so we're just going to take that, and that's going to go here. Okay, and when you work out all that math, you're going to get this. But the question says to round it to the nearest liter to get 49,786 liters, and that's part C. And then finally part D. Okay, the solution that they gave, I think, is super confusing. I did it a different way, which I think makes it a little bit easier, but yet it's still the same answer. So the question is saying, is there a time when R of t is going to be equal to W of t, right, when they're the same? So I will say when I first started doing this, I was trying to find the answer to that, but they're not actually asking that. They're just saying, will there be a time when it'll be the same? They're not actually asking you what is the time. Okay, so here's how I did it. I said W of 0, remember, W of 0 is the water that's going in. So at W of 0, that was 2,000. At W of 8, it was 81.524. Okay, how do I know that? Because I just plugged 2,000 into W of t, which they gave us, and I plugged 8 into W of t, which they gave us. Okay, so it went from 2,000 to 81.524. Okay, then I did the water going out, R of t. So R of 0, this is from the table, is 1340, and R of 8 is 700. So it went from 1340 to 700. So they both go between 1340 and 700, because to go from 2000 to 81, you have to bypass 1340 and you have to bypass 700. So you are going to say, you're going to show all this work, and then you're going to say W of t is going from 2000 to 81.524. R of t is going from 1340 to 700. Okay, by the intermediate value theorem, W of t goes through 1340 to 700. So there must be a value t in which the water pumped in is the same as the water being pumped out. Okay, and that completes problem number 1.